Assalamualaikum warahmatullahi wabarakatuh. Let's continue again our discussion on applications of the derivatives. So now we will talk about the rectilinear motion and the related rates. In this chapter class, you will be able to learn how to calculate derivatives. We use them to solve problems involving rates of change and the approximation of functions. So, dito sa module na to, we are going to tackle the rectilinear motion and the related rates. So, ito na lang yung natirang application of the derivative na hindi natin na-discuss. So, let's go. So one of the main reasons for the inventions of calculus was the need for a way to study the behavior of the objects in motion. For simplicity, we assume that the object is moving on a straight line. The motion on a straight line is called rectilinear motion. Kaya siya tinawag na rectilinear motion kasi yung object natin moves in a straight line. We define the average velocity r during the interval of time t using the formula r equals to t over t, where t denotes the length of the time interval and d is the distance between the initial position of the object and its position after t units of time. Suppose an automobile leaves city A at 1 p.m. and travels along a straight highway arriving at city B 150 miles from A. So which means ang initial distance natin dito is equal to 0 kasi nag-start man siya at city A with a given time t or the initial time at 1 p.m. and then it travels along a straight highway arriving at another city or city B 150 miles. So ang final distance natin dito or yung distance niya after 4 p.m. is 150 miles. So which means the average velocity is magiging 150 minus 0 or d sub 2 minus d sub 1 or final position minus initial position or final distance minus initial distance divided by the final time rather minus the initial time. So 150 minus 0 is still 150 and then ang final time kasi natin dito class na given is 4 p.m. man. So 4 p.m. 4 minus 1 is equal to 3. So that's why ang average velocity natin is 150 divided by 3 which is equal to 50 miles per hour. So ang ginamit na units sa distance is miles and then sa time is r. Okay, so that's an example of your rectilinear motion. So in order to base our discussion on mathematical concepts, let us assume that the position of an object moving on a straight line may be represented by a point P on a coordinate line L. If f of t denotes the coordinate of P at time t, then the function f determined in this way is called the position function for P. Okay, so the average velocity of P during the time interval t equals to a and t equals to a plus h is given by r equals to f of a plus h minus f of a over h. So, pwedeng ma-apply na natin yung atong discussion natin sa mathematical concept. Kasi usually, ang alam natin na topic na ganito is sa physics natin siya na-encounter. So, pwede natin siyang ma-base into mathematical concepts. If a point P moves on the coordinate line L such that its coordinate at time t is f of t, then the velocity b of t sub o of P at time t sub o is given by this. Okay, so ito yung definition ng derivative, diba? Provided that this limit exists. Okay, let s equals to f of t, denotes function of t whose values are distances along lines. Then s equals to f of t is called the position function. So, ito na yung summary nung na-discuss sa previous slide. S is equal to f of t is called the position function of the point P, which moves along the straight line in a given time t, and v of t, or the velocity, is equal to f prime of t. That is the velocity of the particle P at time t. So, ito na yung final na formula ng velocity. Okay, v is equal to f prime of t. Ibig sabihin nun, para makuha natin yung velocity is i-derive lang natin yung given na function. Another is, let f be a function of time t. If f increases with time t, then the rate of change ds over dt, or ds over dt is equal to f prime of t, carries a positive sign. If f decreases at time t increases, then the rate ds over dt f prime of t carries a negative sign. So actually class, etong ds over dt equals f prime of t, equivalent lang yan doon sa v of t equals to f prime of t. Velocity pa rin yan ng particle p at time t. The speed of t at a given time t is v of t. This tells us how fast a particle is moving without specifying the direction of the motion p. The derivative of v prime of t is equal to f double prime of t, or d squared s over dt squared. dt squared is the rate of change of the velocity of p at time t, and it is called the acceleration function of the point p. Kung kukunin naman natin is yung acceleration class, ang magiging formula ng acceleration natin is v prime of t is equal to the second derivative of f prime of t, f of t rather. Okay, kung sa velocity, first derivative, sa acceleration naman is dalawang beses tayo mag-derive. For example, the position of a point P on a coordinate line is given by f of t equals to t squared minus 6t, where f of t is measured in feet and t in seconds. First is find the velocity at time equals to a. So, hanapin natin dito class is yung velocity. So, using the formula of the velocity class, v of t is equal to f prime of t. Yung f prime of t natin, that is the derivative of the given function. So, the derivative of f of t equals to t squared minus 6t is equal to 2t minus 6. So, ito yung gagamitin natin na function para masubstitute natin yung t equals to a. So, when we substitute t equals to a rather, so magiging v of t equals to v of a, which is equal to 2a minus 6 feet per second. So, nilagay ko na yung measured na or yung units na binigay, which is in feet and t in seconds. Okay. Another is what is the velocity at t equals to 0 and t at t equals to 4. So, the same process pa rin sa first na solution. Substitution lang doon sa function natin na nag-derive na. So, using this function, just simply substitute t is equal to 0. So, we get negative 6 feet per second. At t is equal to 4 naman, ang makukuha natin na velocity is 2 feet per second. If an object is projected directly apart from the ground with an initial velocity of 112 feet per second, so this is the given initial velocity, then its distance f of t above the ground after t seconds is 112t minus 16t squared. What is the velocity of the object at t equals to 2, at t equals to 3, and at t equals to 4? So, before natin makuha yung velocity niya class with a given time, kailangan natin kunin yung derivative ng given natin na function. So, the derivative of this is equal to 112 minus 32t. Diba? Kasi derivative ni 112t is 112. Derivative ni 16t squared is 32t. So, we have v of t is equal to f prime of t. So, ito yung formula ng velocity natin, which is equal to 112 minus 32t. So, at t equals to 2, ang velocity natin class, substitute lang natin dito. Okay, substitution lang po. Replace t by 2. So, we get 48 feet per second. And then, at t equals to 3 naman, ang velocity na ma-obtain natin is 16 feet per second. And then, at t equals to 4, that is negative 16 feet per second. Kung mapapansin ninyo, habang increasing yung time, lumiliit yung velocity. Kasi, ito is, galing man siya sa taas, di ba? An object is projected directly upward from the ground. So, the more na tumatagal yung time, pabalik pababa yung object natin, so which means yung magiging velocity natin is magiging negative. So, those are an application of the rectilinear motion. So, let's proceed to the related rates. If we are pumping air into a balloon, both the volume and the radius of the balloon are increasing, and the rates of increase are related to each other. But it is much easier to measure directly the rate of increase of the volume than the rate of increase of the radius. So, tama, di ba? Pag nag-blow tayo, what I mean is, if nag-pump tayo ng balloon, nag-pump tayo ng air into a balloon, lumalaki yung balloon. So, which means lumalaki din yung volume niya at saka yung radius ng balloon na yun. In a related rates problem class, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. The procedure is to find an equation. Okay, take note of this. The procedure is to find an equation that relates the two quantities and then use the chain rule to differentiate both sides with respect to time. Okay, so tandaan nyo to. So we have some strategy in solving problem dito sa related rates. First is read the problem carefully and then draw a diagram if possible. After that, introduce notation, assign symbols to all quantities that are functions of time. And then after, express the given information and the required rate in terms of derivatives. Next is write an equation that relates the various quantities of the problem. If necessary, use the geometry of the situation to eliminate one of the variables by substitution. Use the chain rule to differentiate both sides of the equation with respect to t. And lastly, substitute the given information into the resulting equation and solve for the unknown rate. So actually, medyo disin lang doon sa strategy or steps sa pag-solve ng absolute maximum and minima problems. Minima and maxima problems. So let's give an example. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeter per second. So ito yung rate of change ng volume natin. Okay, tandaan yung given ha. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? So ang tanong, how fast is the radius of the balloon increasing when the diameter is 50 centimeters? So we start by identifying two things. First is the given information and the next one is the unknown information. So the given information class is the rate of increase of the volume of air is 100 cubic centimeter per second. So yan yung given. And unknown natin dito class is yung rate of increase of the radius kasi yun man yung tanong dito. How fast is the radius of the balloon increasing? Okay, so ito yung hahanapin natin. The rate of increase of the radius when the diameter is 50 centimeter. In order to express these quantities mathematically, we introduce some suggestive notation. So let V be the volume of the balloon and R be its radius. Okay, so may mga notation din tayo na gagamitin dito, katulad doon sa minima and maxima problems. Diba may mga binigay doon na helpful formulas. The key thing to remember is that rates of change are derivatives. Okay, take note of this. Change are derivatives. Rates of change are derivatives. In this problem class, the volume and the radius are both functions of the time t. Tama, di ba? The rate of increase of the volume with respect to time is the derivative dv over dt. Ang ibig sabihin nito class, itong dv over dt, yung volume natin is the rate of increase of the volume with respect to time t. Okay, the rate of increase of the volume with respect to time t. And then the rate of increase of the radius naman with time t is dr over dt. Okay, we can therefore restate the given and the unknown as follows. Tandaan niyo yung binigay natin na notation. So given is dv over dt. Ito yung increase, rate of change of the increase of the volume with respect to time t, which is 100 cubic centimeter per second. Then yung mahanapin natin is yung rate of change ng increase of the radius with respect to time t, dr over dt, when r is equal to 25 centimeter. Paki-change yung sa given natin class, 50, pakipalitan ng 25 centimeter. In order to connect dv over dt and dr over dt, we first relate v and r by the formula for the volume of sphere kasi ang given man natin is spherical balloon. So ibig sabihin kailangan natin gamitin tong formula na to. In order to use the given information, we differentiate each side of this equation with respect to t. So to differentiate the right side, we need to use the chain rule. So in order to use the given information class, we differentiate each side of this equation with respect to t. So to differentiate the right side, we need to use the chain rule. So ito yung given natin, dv over dt, which is equal to dv over dr times dr over dt. So actually, ito class, itong sa right side is equal lang siya dito sa left side kasi pwede natin makancel out dito sa dr. Okay, so we left with dv over dt. Babalik pa rin tayo kay dv over dt. So, substitute natin yung value ni dv over dr. Ibig sabihin, ito yung dv over dr kasi a function v with respect to r man. So, ibig sabihin, ang derivative ni 4 third pi r cube is equal to 4 pi r squared. Kasi 3 times 4 over 3 is 4 na lang yung matitira. And then constant man si pi, and then r raised to 3 is magiging 3 minus 1, magiging r squared na lang. And then just copy dr over dt. Okay, eto class, eto siya. And then si dr over dt, pinopya lang. Okay. Now, we solve for the unknown quantity, solving for dr over dt kasi iba yun man yung kailangan natin. So, divided both sides by 1 over 4 pi, sorry, this is 4 half. Okay, 4 pi, this is 4 pi r squared. Okay. So, So, maka-cancel out yung 4 pi r squared dito sa right side natin, and then sa left side, magiging 1 over 4 pi r squared dv over dt. If we put r is equal to 25, take note class, yung sa given natin na 50, pakipalitan ng 25. So if we put r equals to 25 and dv is equal to 1, dv over dt is equal to 100, in this equation, dun sa equation na na-obtain natin class, so we obtain dr over dt is equal to 1 over 4 pi times cr, replace it by 25 kasi given man siya, diba? And then, r squared times etong 100 na yan yung dv over dt. Okay. Which is equal to 1 over 25 pi. Therefore, the radius of the balloon is increasing at the rate of 1 over 25 pi, or approximately 0.0127 centimeter squared. Another example class is a ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 feet per second, so given ito, how fast is the top of the ladder, atong top ng ladder natin? Kasi naka-rest man siya against a vertical wall, diba? So how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Okay. So we first draw a diagram and label it as in figure 1. So ito yung figure 1 natin. So let x, ito class, be feet be the distance from the bottom of the ladder. Ito yung bottom ng ladder natin to the wall. Okay, so ito yung ibig sabihin. And let y fit the distance from the top of the ladder. This is the top of the ladder, the ground. So ito yung sa y. Okay, so x is yan yung sa baba. The distance from the bottom of the ladder to the wall, and then y naman is the distance from the top of the ladder to the ground. So note that x and y are both functions of t, time measured in seconds. Okay, we can therefore restate the given and the unknown as follows. Given natin class is dx over dt, which is equal to 1 feet per second. Bakit siya dx over dt? Kasi yan man yung bottom of the ladder slides away from the wall. So, ibig sabihin, ito siya is given siya 1 feet per second. dx over dt is equal to 1 feet per second. Yun yung given natin. And then, ang unknown, kailangan natin hanapin is yung dito, dy over dt. Okay, ang hahanapin natin class is yung top ng ladder natin sliding down. Pababa siya when the bottom of the ladder is 6 feet from the wall. So, ito yung mangyayari. dy over dt. Bababa yung hagdan, diba, yung ladder. Kasi mag-slide man. And then, of course, change din yung rate ng dx over dt natin. Of course, mag-move din yung ladder, bottom ng ladder natin dito. Okay, so yun yung hahanapin natin ito. In this problem, the relationship between x and y at the class is given by the Pythagorean theorem. So, diba this is a right triangle. Ito yung angle natin dito class. So, we have, diba ang formula ng right triangle is r squared is equal to a squared plus b squared. Hypotenuse side over the adjacent side. Okay. So, we have here, ang ginamit kasi na variable is x and y. So, we have x squared plus y squared equals to 100 because 10, ang squared ng 10 is 100 man. So, ito yung hypotenuse side natin, yung 10 squared. So, differentiating each side with respect to t, using the chain rule, we have, okay, so i-differentiate natin to both sides, each side rather. So, ang derivative ni x squared plus is 2x. Since nag-derive tayo, using, i-derive natin siya or i-differentiate natin siya with respect to t man. So, that's why 2x tapos dx over dt. Dinagdag lang to. And then, si y squared naman, ang derivative ni y squared is 2y. Magdi-derive tayo with respect to t, so dy over dt. And then derivative of 100 equals to 0. In solving this equation for the desired rate, so we obtain dy over dt is equal to negative x over y dx over dt. So ang kailangan kasi nating hanapin is si dy over dt man. So, i-transpose natin ito sa kabilang side. Mag-multiply muna tayo both sides by 1/2 para x times dx over dt na lang yung matira. And then, dito naman, kailangan din natin i-eliminate si y. So, that's why nag-times din tayo ng 1 over y. So, we have negative x over y dx over dt. Okay. When x is equal to 6, kasi diba ito yung given na distance of the ladder from the bottom. Okay, and then the Pythagorean theorem class, substitute natin dito. So magiging 6 squared plus y squared equals to 100. It gives y equals to 8 kasi magiging y squared is equal to 100 minus 36 is 64. Square root of 64 is 8. And so, substituting these values and dx over dt equals to 1. Diba? Yun ang given na dx over dt natin is 1 feet per second. So, we have, gamitin natin to para masolve si dy over dt. Negative, si x is 6, and then si y naman is 8 from here. Okay. And then, si dx over dt, ang given is 1. So, we have dy over dt is equal to negative 3/4 feet per second. The fact that dy over dt is negative means the distance from the top of the ladder to the ground is decreasing. Of course, kasi diba bababa yung ladder na yan. Mag-slide man siya dito. So, that's why negative yung nakuha natin. Okay, it is decreasing at a rate of 3/4 feet per second. In other words, the top of the ladder is sliding down the wall at a rate of 3/4 feet per second. So, eto na yung hinahanap natin. Another example class is a water tank has the shape of an inverted circular cone with base radius 2 meters. So, ito yung radius natin, 2 meters, and height 4 centimeters. So, ang height ng inverted circular cone natin is 4 meters. So, if water is being pumped into the tank, okay, if nalagyan na ito ng tubig, at a rate of 2 cubic meter per minute, okay, so given yung rate ng paglagay ng tubig, find the rate at which the water level is rising when the water is 3 meters deep. Okay, we first sketch the cone, ito yung cone natin, and label it as in this figure. So let B, R, and H be the volume of the water, the radius of the surface, and the height of the water are times T. So where T is measured in minutes. So we can therefore restate the given and the unknown as follows. So ang given natin class is yung dV over dt or yung volume over the time, which is 2 cubic meter per minute. Yan yung water is being pumped into the tank. And then ang hahanapin natin class is yung rate at which the water level is rising. So, ibig sabihin, titingnan natin kung yung rate ng water natin, pag tumaas na siya, ibig sabihin, malaki na yung nalagay na tubig. So, unknown is dH over dt. When ang water natin, ang height ng water natin is 3 meters. So, ito yung hahanapin natin, dH over dt. The quantities V and H are related by the equation. So, gagamitin natin itong equation na to. This is the volume of the circular. V is equal to 1/3 pi r squared h. It is useful to express V as a function of h alone in order to eliminate r doon sa formula ng circular cone natin. We use the similar triangles in this figure. So to write, we have r over 2, which is equal to 2 over 4. It implies that yung r natin is equal to h over 2. And the expression for b becomes v is equal to 1/3 pi. So, diba, ito yung formula ng circular cone. Replace lang natin yung r doon by h over 2. Okay, ito. Substitute natin doon sa r. Quantity squared man, diba? And then times h. So, we have d is equal to pi over 12h cubed. Now, we can differentiate each side with respect to t. So, if we differentiate natin to class dv over dt, so magiging pi over 12 h cubed, ang derivative niyan or differentiation nito is magiging pi over 4 because 3 over 12 is 1/4 times pi. So that's why naging pi over 4. And then si h, yung exponent niya magbawasan ng 1. So that's why h squared na lang. And then i-differentiate natin to with respect to t. So that's why dh over dt. Okay. So substituting h equals to 3 meters. So given ito class. And then dv over dt equals to 2 cubic meter per minute. We have dh over dt. Okay, so dh over dt, solving for dh over dt here, ito yung maa-arrive natin. So, substitute natin itong mga values na to. So, dh over dt is magiging 4 over pi. Si h replaced by 3, and then squared, times yung dv over dt is 2. We have 8 over 9 pi. Therefore, the water level is rising at a rate of 8 over 9 pi, or approximately 0.28 meter per minutes. For the last example class related rates, car A is traveling west at 50 miles per hour, and ito yung car A. And then car B is traveling north. Okay, north. Yung isa papuntang west at 60 miles per hour rather. Both are headed for the intersection of the two roads. And at what rate are the cars approaching each other when car A is 0.3 miles and a car B is 0.4 miles from the intersection? Okay, so we draw figure 4. Atin sa figure 4 natin, where C is the intersection of the roads. So, ito yung intersection nila class. At a given time t, let x, itong x na to, be the distance from car A to C. Ito yung point of intersection ng dalawang car. Let y be the distance from car B to car C. So, since si car A kasi is papuntang west, galing siya dito papunta doon, and then si B naman galing dito papunta sa north. So, ito yung point of intersection nila. So, hahanapin natin ano yung rate na yung dalawang car is mag-approach sila each other. Okay, dito sa intersection na to. Let Z, itong Z na to, be the distance between the cars. Ito yung car B natin, car A. So, tingnan natin, let Z be the distance of the two cars when X, Y, and Z are measured in miles. Okay, so we are given that dx over dt, yung sa car A, diba, given siya, that is negative 50 miles per hour kasi approaches to the, kung ito yung x-axis natin class, let's say may Cartesian plane tayo dito, diba si car A is approaches to the negative side ng x-man. So that's why negative 50 miles per hour. And then si dy over dt naman, yung si car B is negative 60 miles per hour kasi from here, papunta doon, galing siya dito sa baba, negative side pa rin ng y kasi ang positive side ng y is nasa taas man. So, the derivatives are negative because x and y are decreasing. So, we are asked to find ito, dz over dt. Okay, the equation that relates x, y, and z is given by the Pythagorean theorem. So we have z squared, etong hypotenuse side natin, which is equal to the adjacent side plus the opposite side. Okay, differentiate natin siya each side. Wait lang, erase ko to. With respect to t, we have yung Pythagorean theorem, di ba, z squared is equal to x squared plus y squared. So, i-differentiate natin each side with respect to t. So, derivative of z squared is 2z. With respect to t, so that's y dz over dt. Derivative ni x squared is 2x. With respect to t, dx over dt. And then, the same with y. Derivative ni y squared is 2y, dy over dt. So, dz over dt class, kasi yan yung kailangan natin. Multiply tayo both sides by 1z. So, we get 1 over z, x, dx over dt plus y, dy over dt. When x is equal to 0.3 miles, and then y is equal to 0.4 miles naman, so, i-substitute natin dun sa Pythagorean theorem, it gives z is equal to 0.5 miles. So, substitute natin dito sa function na construct natin. So, dz over dt is equals to negative 78 miles per hour. So, the cars are approaching each other at a rate of 78 miles per hour. Last example na talaga to sa related rates. A man walks along a straight path at a speed of 4 feet per second. A searchlight, okay, ito yung speed ng lalaki na naglalakad. A searchlight is located on the ground 20 feet from the path, okay, and is kept focused on the man. What rate is the searchlight rotating? Ito yung tanong, what rate is the searchlight rotating when the man is 15 feet from the point on the patch closest to the searchlight? So, we draw figure 5. At yung sa figure 5 natin, let's say, ito yung lalaki. Naglalakad siya from the path, 4 feet per second yung speed niya. Okay. Let x, itong x na to, be the distance from the man to the point on the path closest to the searchlight. And then, let theta be the angle between the beam of the searchlight, okay, and the perpendicular to the path. Okay, so ito yung theta natin. Be the angle between the beam of the searchlight and the perpendicular to the path. So, we are given that dx over dt is equal to 4 feet per second. So, ito yung speed ng lalaki na naglalakad, and are asked to find the theta over dt. So, ang tanong kasi, what rate is the searchlight rotating when the man is 15 feet? Okay, when x is equal to 15. So, ito yung goal natin. So, the equation that relates x and theta can be written from figure 5. So, x over 20. So, this is a right triangle. So, ang x natin is that is the opposite side divided by the adjacent side, which is equal to tangent theta, or sine over the cosine, that is tangent theta. So, solving for x is equal to 20 tangent theta. So, differentiating each side with respect to t. Okay, differentiate natin to with respect to t. Derivative ni x is 1. So, since mag-derive tayo or differentiate tayo with respect to t, so that's why dx over dt. Okay, derivative ni 20, what I mean is the tangent is secant squared. So, remains si 20, that is a constant. So, secant squared theta, e theta. So, yung tawag dito, d theta over dt equals to, okay, solving for d theta over dt doon sa na-obtain natin na formula is equal to 1 over 20 cosine squared theta dx dt, or this is equal to 1 over 5 cosine squared theta. Excuse me. So, when x is equal to 15, the beam of the light is 25. So, cosine theta is equal to 4 over 5. And d theta over dt is equal to 1 over 5. Substitute natin dito. Times yung cosine squared theta natin. Cosine theta natin is 4 over 5. Quantity squared, which is equal to 0.128. Therefore, the searchlight is rotating at a rate of 0.128 rad per second. So those are the examples of related